We've added our AXDX. We're almost done. We just have a jump greater than, and I didn't code this yet, so we're going to code it out now. Our instruction is jump greater than or equal to. We're just going to copy this in here. Our CS, this is our current spot, our IP, the instruction pointer, is going to be at 110. Our operation is obviously a jump greater than or equal to. Our destination is going to be 114, and we do not have a source. So for our instruction format, we're going to look inside of here. We see that we have a conditional jump, so we're going to be inside of here is a JGC or a JCC. So that is a conditional jump. And then inside of here, we have a few things. First is our 0, 1, 1, 1, and then we have our TTTN. Now we've done this very similarly before, so it's going to be the same. We are always using the 8-bit displacement for the program that we are writing in now. So we have 8-bit displacement. And now we can start plugging in these things to our binary. So for our binary, we have a 0, 1, 1, 1. That's going to give us a 2 to the 0th, that's 1, 2 to the 2nd, that's 2, so that's 3, plus 2 to the 4th, so that is, or this is 2 cubed, so that's 8. So basically I have 8 plus 3, which is 11, which should be B in hexadecimal, but we'll go back and check that if I did my math correctly. And now we have our TTN. So that's going to be this conditional test field that we've gone over previously. And so for the conditional test field, we have a 8-bit displacement of it being greater than or equal to. So if we find that, it should be not less than greater than or equal to, which is going to be this 1, 1, 0, 1. And then we need our 8-bit displacement. And to find our 8-bit displacement, what we're going to do is we're going to take whatever location that we are jumping to. In this instance, it's 114. We subtract it to the location we were at right now, which is 110. And then we subtract it from our instructions, I believe it was. If we scroll back up here, yeah, it's the instruction size. So that's going to give us a 4 here. And the instruction size for a jump is a 2. So with this one, it's just going to be 0 or an underscore 0, 0, 1, 0. And so that means in hex, this should be a B because this should have a 0 out front. We'll just do this like that. So we have 0 here. And then this one, I think we said, I don't remember what we said, but we can check it here. So for a jump greater than or equal to, it should be actually be a 7D 0 6. And so I calculated this wrong. This is not a B, this should be a 7. You can see that if you use a binary calculator. I just used a binary calculator and fixed it right up. And so for a binary calculator also, if we were to plug in our 1101, that would give us a value of, it's not really showing it, which is unfortunate, but I believe this is an 8 plus 4 plus 1, so that's like 13. So that should be a D. So we have 7D. And then next we have our place right here, and this is just going to be a 2. And so if we look back up here at what we've done previously, it's going to be O2. So in our instruction size, we're going to just have O2, and then we can just plug it into our hexadecimal. So in here we have 7D02. That is going to be the answer for this hex one. Lastly, we have this move, and then we are going to have our ending one. That's going to be it for our hand assembly.